So in this video we're going to look at arithmetic shifts. One of the objectives is to be able to use arithmetic shift functions and actually explain the effect. So the first thing that we need to understand is why we're actually using arithmetic shifts for. Arithmetic shifts are used to multiply and divide binary numbers. Not only that, we need to understand the effect that the shifts both left and right have on a binary number every time you shift it either left or right. So the first thing we're going to look at is a left shift and then a right shift. The first thing you need to understand is that a left shift enables us to multiply a binary number. So looking at a left shift, I've just made a few notes so far. So left shift, I must always remember that this will multiply a binary number. So for example, the number 001100, which would equate to 12. A shift by one place to the left would give the answer 24, which is the equivalent of multiplying the number by 2. So to put this into practice, is one of our objectives to actually be able to use an arithmetic shift. I'm going to take the number and actually enter it in binary just so we get a better understanding of what's actually happening. So I'm going to put the number in 001100, and although this hasn't been entered, I'm going to put the other zeros in there as well. So this number is 12 because we've got a 1 in the 8 column and a 1 in the 4 column, and by adding them together gives us the answer 12. But we need to perform a shift by one place to the left. What this is basically meaning is that these numbers here will be shifted one place to the left. Now actually carrying this out would mean we would cross out the number here, and all of these numbers would then be moved one place to the left, which I'm going to fill out now. So 000110. Now everything's being moved one place to the left. There's still a remaining gap there, and all I'm going to do is fill that out with a 0. Now as you'll see, the number is 24 because we've got a 1 in the 16 and 8 column. By adding them together gives us the result of 24. So that would actually be in the Gcse exam 1 mark just for actually performing a left shift by one place. But you need to understand what's actually happened. By moving it one place to the left and shifting these numbers across, it's the equivalent of multiplying the number by 2, meaning the number's actually doubled. But what would happen if we do a left shift by 2 places? So as you can see, I've re-entered the number that we start with, 12, and placed it here. So if we were going to do a shift of 2 places to the left, how would we actually perform this? In the same way, but not just one number, 2 numbers, we'd take the numbers from the left and cross these out, and move all of these numbers that are remaining 2 places to the left. So this 0 will move there, this 0 will move there, the 1 will go here, the 1 will go there, and so on and so on and so on, which I'll perform now. Now as you can see, I've got a gap there because there's no more numbers moved across by 2 places, and all I'll do is I'll fill these out with 2 zeros. Now why is the number 48? You'll notice that I've got a number in the 32 column and the 16 column. If you were to take these 2 numbers and add them together, the number would be 48. Now this is the equivalent of multiplying the number by 4. So the original number 12 is being moved 2 places to the left, which is the equivalent multiplying it by 4. If you were going to do this by 3 places, it would be the equivalent of multiplying it by 8. 4 places would be 16. Every time that you shift a number over, it doubles every single time. So now we're going to look at a right shift. Now where a left shift would multiply the number, the right shift would actually divide a number. So if we start with the original example that we did before with a number of 12, you can see I've entered it in here into the table. a shift by one place to the right would give 6, which would be the equivalent of dividing the number by 2. Now, how will we actually perform this to get a mark on the GCSE question? What I would do is I would take the one number from the right, and all these remaining numbers will be shifted one place to the right. So this 0 will be placed here. The 1 would come across into the 2. The 1 in the 8 column would come into the 4, leaving with me the remaining zeros, which I'd enter in. You'll notice that there's a gap there. It's a case of simply filling this out with another 0. And the answer is 6 because you've got a 1 in the 4 column and a 1 in the 2. These two numbers added together equate to 6, which is the equivalent of dividing by 2 that we started with. So 12 divided by 2. If we did exactly the same thing with the original number 12 and did a right shift by 2 places, this would give us 3. But why? We take the numbers that we originally had and we bring all of the numbers across by 2 places. So if I put the original number in so you can see, which is our original number of 12. If we were going to perform a right shift by 2 places, I'll take these two end numbers off, and all of these numbers will be shifted 2 places to the right. Again, I will be left with 2 spaces because I've shifted everything across, and I'll just fill these out with the zeros. The reason that this would be 3 is because I've got a 1 left in the 1 column and a 1 in the 2 column. Adding 2 and 1 together will equate to 3. Now, taking out moving these numbers 2 places to the right, meaning that it's equivalent to dividing by 4. If I was to go to right shift by 3 places, divided by 8, and every time I move it to the right, it's double the time. So if we have a look at this GCSE question, it's asking us to perform an arithmetic shift left by 3 places on a 16-bit binary number. And state the effect this has on the number. Now, one of the first things I would be paying attention to on this is that it's 2 marks. You're getting 1 mark for actually performing the shift left by 3 places on the number, and another mark for stating the effect that it has on the number. So the first thing I will be doing is I'll be writing out that number, then performing the actual shift by the left by 3 places. So using our knowledge from before, I want to do a left shift this time by 3 places. So I'm going to take the first 3 zeros out, and all of these numbers here are going to be shifted 3 places to the left, which now becomes 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, followed by the 3 zeros in its place, giving me a 16-bit binary number, and all of these numbers that were remaining before have all been moved over 3 places to the left. So there's my 1 mark out of 2 for performing the actual shift by 3 places. But what's the actual effect that it has on the number? So to get my next mark, I'm literally going to write the effect that it has on the number. Moving it by 3 places has the effect of multiplying the number by 8. 1 place will be 2. 2 places will be the equivalent of multiplying it by 4. 3 places in this case is the same as multiplying the original binary number by 8, or 2 to the power 3. And as you can see in the actual exam paper mark scheme, there's 2 marks available. And as you can see, the number is the same that I've got there, so there's my 1 mark. And I've stated the effect. It's the effect of multiplying by 8 or 2 to the power of 3. So the one thing that you might need to be paying attention to on this is GCSE questions could be asking you to do a left shift or right shift. You need to understand that a left shift is going to increase a number by multiplying it, where a right shift will divide it. One place will either multiply divide them by 2. 2 shifts will again double it to 4. 3 shifts will be the equivalent of multiplying by 8, where 4 shifts will be the equivalent of multiplying and dividing it by 16.